All right. Well, cool. Hi everyone, my name is Andrew Macht. I am here to stream on how to use my kind of technique on how to de-hum. Um, I don't know if it's right, wrong, or anything. Feel free to let me know if it's incorrect. Anyways, here we go. So I already have uh, the Izotope RX7 monitor plugin already inserted on a work track that I have created here. And I already have our clip that we will be working on to see the hum that we'll be dealing with. So let's go ahead and actually send that over. I actually have this pulled down from Audio Suite already. And I actually have something sent there right now, but we'll just click repair again, make sure that's set to 0, and send it over. It's going to ask me that I want to save. I'll say no. And let's go to the standalone view. And one thing I noticed right away is I am missing my spectral editor. Where the hell did that window go? That's a good question. Give me one sec here, find out where. There it is. I found you. Had it in full screen mode. So anyways, I have this now sent over to Izotope RX7 standalone, and as you can see here, we have a hum already present. Let's go ahead and close that real quick. Actually, it looks like you cannot see that. One sec here. Let's get that in the view. Wow. I did not know that. Just one sec. I gotta get this in the view for you guys. So there is our hum showing up here. Let me get it a little more in the view here to see what we're dealing with. So yeah, we got our hum here, here. Looks like some minor ones here, here, and here, and even there's some right in there. The ones that are more bright orange just mean they're louder in volume, and mainly the offending ones. These ones here that are less dark, or I shouldn't say less dark, more dark, are lesser in volume and not as likely to be heard. So we definitely wanted to concentrate on this, this, and this in order to de-hum this track. So with further ado, I'm going to go ahead and actually play this back just so you hear what we're dealing with.
The birthday after that, last year, wasn't so great. My ex-wife and I had gone to dinner, actual dinner at a restaurant, no surprise party this time, and then to see a movie. There were awesome explosions, and the guy kicked everyone's ass before coming home to a hot, grateful blonde who didn't give him any shit.
Okay, so as you can hear there is some hum in this track, and you can actually see it literally in the track. We are going to be removing each of these harmonics out of that hum, and we're going to be doing it with the de-hum module. So let's go ahead and pull up that de-hum module. I actually forgot the shortcut keys on each of these modules. I had them memorized for the longest time, and now I don't remember them anymore. First off here, we need to determine what our range is for this frequency. So actually, I'm going to close that de-hum module again here, I'm going to actually zoom up on this particular portion and get a nice zoomed in view here, just to narrow down on what we are working with currently. And just out of a general guess, it looks like we're dealing around 174.5. But to make sure that we are accurate, we are going to make the frequency selection between the highest frequency and the lowest frequency. Sorry, a little hiccup there. And then we'll come down here where we got kind of our view. I forgot what this portion of Izotope RX7 is called, but we have our selection data information. So we got our lowest frequency here and our highest frequency here, and then the range between the two. We want to take that range number and divide it by 2. So what I do and like to do is I pull up a calculator. Now I have this calculator pulled off on my right hand screen, so you're just not seeing it. I just take out a calculator and do the math here, but it is 9.68, so we are going to take 9.68 and divide that by 2. Dividing that by 2 gives us 4.84. So the frequency in the De-Hum module only goes to the 10th value and not the 100th value, so we actually round up or down. So anyways, now that we have that, we can go ahead and pull up the De-Hum module. I use RX7 quite a bit. I actually have some configuration here that I've previously used, and I am going to set this to default just so you have an idea what you deal with when you first load it. So we first want to look at the base frequency here. By default it's 60 Hertz. We want to bring this down to free. This will allow us to change our selection. Looks like my top camera just died on me, but that is totally fine. We'll just keep rolling it through this. So anyways, talking about the frequency here, we changed that to free to allow us to be able to type in a value here for the frequency. The next thing I like to do is we are not going to be using all these harmonics. So let's bring out all these harmonics and bring it down to 1. And there we go, got it to 1. By default value, the Q value is fine. We definitely want that notch to be as tight as possible when we're trying to do this. Sometimes we'll make it slightly wider, or I like to make it slightly wider. If the frequency here, the harmonic of the hum, is occupying a few more frequency values. Anyways, so now that I have my calculation here for the range and divide that in half, which is 4.84, I actually need to do one more thing and calculate it into the lowest value frequency. So just going back to my calculator real quick here. So 4.84 plus 1.68.03 is what I have there. I'm actually quite blind, so I'm sticking my face in the screen here. Yeah, 169.03 is the value that I have here. 0.03, yeah, okay. So we go add, and then 169.03, and we get to 173.87. Bring in that De-Hum module again, and make sure our selection's there. Yes, you saw me, I lost my selection there, and yes, it may or may not screw up what we're doing here, but I'll get to that in a second. It's fine as long as we have our number that we need. 173.87. And like I said, the 100th value is not used, so ignore me on what I just said there and round to 0.9. And go ahead, hit render. And yeah, that did her. So just Command Z that real quick. I was able to successfully hit that frequency right in the center value and completely wipe it out. And now it is no longer even there. So that harmonic of the hum is gone now. I can play that back, and yes, you should always play it back just in
The birthday
case
after
you
that,
introduce
last year,
harmonica.
wasn't so great. My ex-wife and I had gone to dinner, actual dinner at a restaurant, no surprise party this time, and then to see a movie. There were awesome explosions, and the guy kicked everyone's ass before coming home to a hot, grateful blonde who didn't give him any shit.
And that was harmonic distortion, by the way. Sometimes doing this, so that's not always the perfect thing, but sometimes you can introduce harmonic distortion. And essentially what I'm talking about is trying to do a large frequency selection like this across a full clip can sometimes potentially damage the voice harmonics and the tonal of it, causing some weird distortion with vibratos and stuff like that, where you'll hear a weird harmonic distortion and warbliness from the removal. So always listen to playback after you make a removal of one of the harmonics of a hum. Yeah, and like you should always listen to what you are correcting. So let's go ahead, let's take a peek at what we got going on this hum here. Let's dive in, move in, and we are looking at 119.5 at the moment, maybe 119 for the center value. Again, let's pull up the frequency selection tool. F is that shortcut key if you are wondering. And here's our section value, and let's go ahead and again let's look at our range here, and we now have 12.65. So let's go back to our calculator, go 12.65 divided by 2 to get us 6.325. And then our other value that we are going to be looking at here is 112.14 for our lowest frequency selection. So 112.14 equals 118.465 is the frequency that we should be trying to remove. So let's go back into the De-Hum module, and under frequency, let's go ahead and type in 118 point. We got around 0.5, and we should be at our value. Let's see. So now you just noticed the problem here. While doing this, I was actually off on my calculation here, and I'll show you why. Like the last frequency, I'll zoom out. Like the last frequency, I was able to hit it right on the dead spot. It looks like I did some damage to it, but not significantly. I hit it, but you can see there's still hum here. It's definitely less, so I did something. It's just I didn't hit exactly on the spot. To know that you hit exactly on the spot, this entire line should disappear. So what you can do is hit Command A, find out how much you're off. So if you go like this, you sometimes get an indication. I'm like right there. Give me one sec here. Let me figure this out. Our lowest value is, hold on one sec. Our lowest value that I have here is 107, and our highest value is 140. How in the hell? Let's see here. Let's do that again. Let's look at this. Our value is 107.59133. I think I was off because I entered 118. Let's redo our math here real quick. 23.34. Yeah, 23.34. Oops. Come back here, 23.34. Divide by 2. I got 11.67. Let's add in 10759. So 107.59 equals 119.26. So interesting. And that would be 119.3 that we enter into the De-Hum module. Let's go ahead and try that value. 119.3. And it, let's see, did I hit it? Command C. That's annoying. I didn't hit it again. One sec here. We are going to make sure we nailed it with this method. So this is now where we get into a little bit of a guesswork. We're at 109.30. And we see 130 there. So anything below 119 should be our indication of what we're looking for. So let's enter in 1192. 119.2. That was incorrect. Let's try that. That's still incorrect. 9.1. Still incorrect. 0.0. Still incorrect. I feel like we're going down. 118.9. Well, we are going down, but you see, we're still not removing it yet. Let's try the opposite way. Go 119.4. I feel like that did some damage. Maybe 0.5. No, 0.4 looked like it's better. Yeah. You know what? I'm going to go back to 119.3 because that's where my math told me. except actually I lied. I like where point 4 looked. You know, now I'm just kind of being stupid about this. Listen back to playback, make sure it's good. If it is quiet, then you're fine to continue on. I'm struggling a little bit here trying to get the exact value and trying to figure this out. I just don't want to make this video too long, just with me trying to go back and forth, trying to hit it. But if you do the calculations here correctly and get the right frequency, which you'll see is the entire frequency value here will actually disappear if you hit it right. It's possible that this is in the 100th value, and that's why I'm not hitting it. But I'm definitely sitting somewhere right on top of it, which is okay. I'm not going to ever say do this, but you can widen this value. And then hit it, and it's gone. So, yeah, you can do that, but you're taking more frequencies away than you should. That's why I prefer to stick as narrow as possible when trying to hit the right frequency. Yeah, it could be between that 100th, and widening this will actually potentially get us to that threshold. And now you're making me think. All right, it's too late at night for me to be looking at it like that. We're going to just move on, and we got one more to look at. But essentially, you got the idea at this point. Feel free to stick with me here. I'm going to just do this last one just to make my point. So, this is just a method I do. And yes, this is not necessarily a tutorial video. I don't know how to, I'm not a streamer. That's all I gotta say. But anyways, here's my range again, my selection from the frequency selection tool that I've created. We got a range at 5.63. Go back to our calculator, type in 5.63, divide that by 2, we got 2.815. Add that to our lowest frequency value, and that is 55.29. So 55.29 equals 58.1. And yes, again, I'm rounding. It's actually the full value is 58.105. I am rounding to 58.1. Let's pull out our De-Hum module again and change its frequency value to 58.1. And let's find out if we're good. And boom, it is demolished. That's what it was, and that's where we got to. Let's listen to playback.
The birthday after that, last year, wasn't so great. My ex-wife and I had gone to dinner, actual dinner at a restaurant, no surprise party this time, and then to see a movie. There were awesome explosions, and the guy kicked everyone's ass before coming home to a hot, grateful blonde who didn't give him any shit.
There's a frequency up here. But yeah, that's shall do it. It's actually a lot quieter now. It's not as bad. So let's do the before.
The birthday after that, last year, wasn't so great. My ex-wife and I had gone to dinner, actual dinner at a restaurant, no surprise party this time, and then to see a movie. There were awesome explosions, and the guy kicked everyone's ass before coming home to a hot, grateful blonde who didn't give him any shit.
Then let's listen to the after.
The birthday after that, last year, wasn't so great. My ex-wife and I had gone to dinner, actual dinner at a restaurant, no surprise party this time, and then to see a movie. There were awesome explosions, and the guy kicked everyone's ass before coming home to a hot, grateful blonde who didn't give him any shit.
And there we have it. So thanks for watching. Hopefully you learned something from how I handled dehumming my tracks. Yes, I use the de-hum module all the time and prefer this method. Usually always am able to hit the right frequency. When you do get these harmonic distortion issues I've mentioned a little earlier, I render around those. So usually, yes, I attempt the entire clip, but when I do see the harmonic distortion or hear that harmonic distortion pop up, I'll make, the selection up to that point or just a little before it and render that side and then jump past that and then render the other half. And then we're all set and everything actually works just fine from there. So again, thanks for watching. I hope you learned something. Have a great night.